Hello, welcome to a revision lesson on the electrolysis of molten ionic compounds. We're going to have a look at three things associated with the electrolysis. Before we start, it's worth reminding ourselves what these words mean. Electrolysis means the decomposition or breaking down of an ionic compound using electricity. The word molten here means that it's melted. We use the word molten because it takes place at a high temperature. An ionic compound is obviously a compound made of metal ions and non-metal ions. So, and all of this I will make sure we make some notes of this as we go along. So we're actually going to look at an electrolysis that we would have done in the lab, because we can just about do this one, because we're looking at the electrolysis of lead chloride. So we would have seen a container, and that container would have been heated strongly so that we would have produced molten lead chloride. Okay, the formula for that is PbCl2, and I put an L after it to show that it's liquid or molten. It's important that it is molten so that the ions that are in that make up lead chloride, so the ions are able to move. If we were to carry out the electrolysis with solid lead chloride, nothing would happen because the ions were not able to move. And suspended in the molten lead chloride, we'd have had two electrodes, a positive electrode and a negative electrode, which we connect to a power supply. So I'm just going to put here as a 12-volt power supply. And we would see two things happening. At the positive electrode, we would see chlorine gas being produced, and at the negative electrode we would see lead being produced, so lead metal. But obviously this is taking place at a high temperature because it's molten, so the lead metal would likely be molten as well, or liquid as well. So if we think about the things that are actually happening here, we have lead ions, which we're going to give the formula of Pb2+, and those lead ions become lead atoms. So notice that we had Pb2+, which is the formula of a lead ion, so it has a charge, and it becomes just Pb, that's the symbol for lead, and it no longer has a charge. So something's happened for it to go from Pb2+ to Pb. We would also have seen our chloride ions, which have a Cl- charge, become chlorine molecules. So Cl2, notice that we're actually going to need 2 times chloride ions to do this, but our chloride ions, the important thing here is that this negative charge has disappeared. So we've gone in both cases from something that has a charge to something that is neutral, from ions to atoms, or in the case of chlorine to chlorine molecules. So we're going to think about how that happens in the electrolysis process. So what's happening at the two electrodes? Let's look at that positive electrode, which is probably a little bit more straightforward to understand. Okay. Sorry, actually we'll start with the negative electrode, which is probably an easy one to understand. Right, so with the negative electrode, we're going to see Pb2+ ions, so that's the lead that has a 2+ charge that's in the electrolyte, that's in the molten lead chloride, and that's going to move to the negative electrode, and it's going to gain 2 electrons, so 2 negatively charged particles from the negative electrode, and that 2+ charge and the 2 negatives here are going to neutralize the charge on the lead, so it's gained 2 electrons and it's become lead atoms. The positive electrode is a little bit more complicated to understand because the first stage makes sense in what happened with the last one. So the chloride ions, which have a negative charge, are attracted to the positive electrode, the opposites attracting, and each of these chloride ions is going to give up or release an electron to the positive electrode. So we're neutralizing or getting rid of that charge. That minus charge is being given to the positive electrode. And what happens is those two chloride ions that become chlorine atoms then immediately join together, and we get a Cl2 molecule being formed. But the really key thing is that at the negative electrode, the Pb2 plus ions gain 2 electrons to become Pb atoms. At the positive electrode, the Cl minus ions release their electrons to become chlorine atoms, and then 2 of them stick together to make a chlorine molecule. So how do we represent that in chemistry? Well, we use something called half equations. So our half equation for what happens with the lead is Pb2 plus gains 2 electrons, so 2 positives and 2 negatives, to become Pb. What happens at the positive electrode? There's 2 ways we could show what happens here. We could say that 2 chloride ions, 2 Cl minus ions, lose 2 electrons, so minus 2 electrons, to become Cl2, like that. That's one way we could do it, and actually it isn't incorrect to do that, but it's much better if we actually do it this way, because subtracting things doesn't really happen in chemical equations. So rather than saying subtracting 2 electrons here, what we're saying is that 2 electrons are produced. So we can use this to some extent if we want, but it's much better for us to use this one. So our 2 half equations to show what happens at the 2 electrodes are there. So I've got a tick next to that one to show that's the one that we want to use as well. Let's just have a look at the whole sheet now, just to see what we have produced here and what's going on. I think I can just about get it all in. Yeah. So I'm just going to have to accept that we can't quite get the 12 volts in at the top there. So this is what we see. We've got molten lead chloride, so that's going to have been melted at a very high temperature, and remember it's molten so that the ions are able to move. And in that we've got 2 graphite electrodes, one that's attached to the positive terminal of a power pack, one to the negative terminal. We're going to see chlorine gas being produced at the positive terminal, and we're going to see molten lead metal being produced at the negative electrode. What's happening is the lead ions, the Pb2 plus ions, are becoming lead atoms, and the chloride ions, the Cl minus ions, are becoming chlorine molecules. In both cases they no longer have a charge. So we had a charged ion here going to a neutral atom, a charged ion here going to a neutral molecule. The reason that's happening at the electrodes is because in the case of the negative electrode, the Pb2 plus ion is attracted to it because it has an opposite charge. It gains 2 electrons to become a Pb atom. At the positive electrode, we have 2 chloride ions, 1, 2, moving to the positive electrode because it has an opposite charge. Each of these lose an electron. They join, the 2 atoms that are formed join together to make a Cl2 molecule. We show that here, Pb2 plus 2 electrons. Pb2 plus 2 electrons makes Pb, and Cl minus, so our Cl minus is here, releases 2 electrons to the electrode, that's those 2 there, and produces a chlorine molecule here. Thank you very much.